Hello, welcome back. In this video, we're going to continue what we did last time. We're going to look at how to solve transportation problem using least cost cell method. Now, about least cost cell method, of course, we identify the cell which has the least cost amongst all the cells that you've been given in the transportation problem. So, for example, here you can see there are 3 here. The cost of cell, the first cell here is 3. The cost of second cell is 1, 7, 4, 2, like that. So if I check all of it, the last cell with the least cost is 1. Now it may present itself again where you have 2 cells which have similar, or maybe which have 2 least cost time. So when that happens, you need to select the cell which has the highest demand of the 2. So you select the cell which has the highest demand. You're going to check the demand destination, then be able to pick that one, then followed by the other one. So in this case, I'm going to start by allocating to the least cost cell here, which has the cost of 1. So this is the first cell I'm going to allocate. All right. So let's check the demand of this cell. So you can see the demand is 350. Now the availability is in source 1, which is 300. So I can be able to allocate the 300 here. All right. So 300 here. Then I'll be able to finish the supply of source 1. Then therefore the demand here remains to be 50 after allocation. So therefore it means this cell has been, the supply source 1 has been fully exhausted, and therefore it does not have anything more to offer to other cells. So I'll close that, I'll close this row, or maybe I'll close the row, so that the row number 1 is no longer participating in the next decision. Now I'll come to repeat the same again. I'll check which cell now has the least cost amongst this. So you can see here we have 2, then we have 2. So we have the next least cost is 3. So I have 2 and 2. So I have 2 cells here. So as I've said, you have to pick the one which has the highest demand, because 2 and 2 here are tying. So I'll pick this one. This one has 250 demand. The demand here is 200. So I'll pick this one first. I'll start allocating it. So I'll allocate from the supply. So I have 400 here. The demand is 250. So I'll give 250. So what remains here is 150. Then I have fully supplied this supply destination. So that means also I'll close this first cell. All right. So I'm done. Now I will go to the second cell and see. Now from the remaining cells, of course, I have these other cells remaining. So I have 6, 5, 9, 3, 3, and 2. So 2 is still the lowest cost cell. So I'll just allocate. So you can see the demand here is basically 200. Availability is 500. So I'll give 200 here. So that means no more needed here. The demand destination 4 is fully supplied. So I'll remain here with 300 as supply. So therefore it means this cell is complete. So I'll have to close it down. So I have only 4 cells participating now. I have 6, 5, this one, this and that. So those are the only cells remaining. Now I identify the cell with the least cost. So the cell with the least cost therefore is these 3 and 3, but remember they are tying. So I have to allocate what is needed here. So let's see the availability here. We have this cell here. We have we need 400. The availability here is 300. So I'll have to give 300 what is available. So that means we have completed the supply here. Then I'll still need 100 here. So therefore it means because supply source 3 has been fully exhausted, I'll close that row. So we no longer need this row. I'm closing it down. So this leaves us to remain with only 2 cells. We have this cell and this. So the least cost cell, of course, this one here. So this cell here, 5, is the least cost. So if you look at the demand, we need 100. So I'll allocate 100 from here. So 100, I'll remain with 50 here. So 100, I'm fully supplied this destination 3. Now finally, The remaining cell is this. So you can see the demand is 50 and then the supply remaining is 50. So I would have fully allocated in the cell. So I'll have 50, and then here 0, here 0. So from that allocation you can see I have fully allocated the supplies into destination successfully. Now I can be able to find my minimum cost by multiplying what I have here. So I check my allocation, so I have 250 multiplied by the cost cell, which is 2, then 300 plus 300 multiplied by 1 plus 50 multiplied by 6 plus the next one is 100 multiplied by 5 plus the next one is 300 multiplied by 3 plus the next one is basically 200 multiplied by 2. So when we do the final calculations by adding all that, we're going to have total cost. So you can see what we can get by using our calculator and see. So I have 250 by 2 is 500 plus 300 I have 800 plus 300 that gives me 1100 plus 500 that gives me 1700 plus 900, so I have, that gives me 2600. I add 200 by 2, that is 400, so that gives me 3000. So this is basically what I'm going to have, $3,000. So this is basically how you work out a transportation problem using the least cost cell method. So we're going to check the next method in our next video. Hello, welcome back to our class. So in this video we're going to learn about how to solve transportation problem using northwest corner cell method. So we're going to use what we call northwest corner cell method. Now, using northwest corner cell method, it requires you to identify the most northwest corner in the transportation problem. So in this case, I've just brought back the transportation problem that we're going to use to solve that. So you can see here, if this is your compass, of course, this is always your northwest, all right? So you can identify the cell here, because I've told you these are cost cells. You can identify the cell which gives us, or which is in the most northwest corner. So you can check here and see that this first cell here is our most northwest corner cell. That's our most northwest corner cell. Then that's the cell we are going to start by allocating the resources that have been supplied here. Remember, in our previous video we did balancing of the problem. Of course, you add the values, of course, to make sure that our problem is a balanced transportation problem. Alright, so this one is a balance. We add the values here. I've already added, and then we have 1200 as our values. Now, so we start allocating the first cell, which is in the northwest corner. So we have the demand here is 250. The supply is 300. So I will allocate 250 here. Then you can see what remains here is 50. So I'll remain with 50. Now, on this cell, I have fully allocated what it required. So I have fully allocated that cell, what it needed. So we remain with demand of 0 here. So therefore, that means I have to close this column for demand destination 1, because it no longer participates since we have fully supplied what it needed. So I will close this cell. Alright. Now we'll identify from the remaining cells. So the remaining cells starting from here, this cell O1, D2, O1, D2, O2, D2, and so forth. So we have all these other cells remaining. This is where now we are going to identify our next northwest corner. So our next northwest corner is going to be found here. You can see that. We are still following the most northwest corner. If you put your compass here, this cell here is our most northwest corner. So let's look at the demand. The demand here is 350. The demand is 350. So you can see how much do we have in the supply, so we have 50. So you can allocate the 50 that we have, all right? Then it means here we still need 300 to be able to serve the demand destination 2. So I'll have 0 here. So therefore this means also I have fully exhausted supply source 1, and therefore it has nothing else to offer. So it's not going to participate again in the next allocation. So I'm going to close this row. Okay, so I have closed that row. So I have only these cells remaining, these ones. All right. So I can see from my cells, the most northwest corner part is this. So this cell here, which is in cell number O2D2. All right. So this cell here is going to be our northwest corner. So I will allocate. So I look at the demand. The demand again here is 300, and then we have the supply is 400. So I'll give 300 what it needs. So what remains here is 100. Then basically I have fully supplied this. So this tells me that I have fully supplied destination 2. So it will not participate in the next allocation. So I'm going to close it. I'm going to close this column. So I'm remaining with these cells now, these 4 cells here. Then my most northwest corner, again, I identify it's this. It is in this cell here, which has cost of 5. So whatever is available here is 100 supply in source 2. And then the demand is 400. So I'll give the 100 which is available. All right. Then source 2 has fully supplied what it had. So therefore it means I will have to close this source 2 since all the resources available has been exhausted. So it will not be able to participate in the next allocation. So I close that cell. Now I'm remaining only with these 2 cells here. All right. So I can start with this. This is the most northwest corner. I allocate it again. So I have, it needs 400. Availability here is, sorry, this one is not 400, of course. I forgot we did this, so this one is supposed to be 300. Remember that we had allocated 100 here in destination 3, yeah, from this. Then, so what was remaining is 300. So that means now we only need 300 to fully satisfy destination 3. So I will allocate 300 from this. So I have fully supplied that destination. So my last cell is this. So I'll have to allocate what is remaining. Of course, I have given here 300, 200 remains here. Now, so this last cell here, the demand destination 4 needs 200. So what is remaining is 200 in the supply source 3. So I will allocate those 200. And I would have fully done my allocation in that cell. So to get the total cost of transportation using the northwest corner cell method, I'm going to multiply each like this. So I'll say 250 times the cost of that cell. I mean each cell allocated plus 50 times 1 plus the next cell. So we have 300 times 6 plus the next cell. I have 100 times 5 plus the next cell. I have 300, of course, the second 300 times 3 plus the last one. I have 200 times 2. So if you do a calculation, this one is going to give us total cost. We are adding all these values, so 250 times 3 plus 500 times 50 times 1, sorry, plus 300 by 6 plus 100 by 5 plus 300 by 3, and that. This one should give you a value like 4,400. So this is the total minimum cost of transportation using the northwest corner method. So in our next video, we're going to see how to use least cost cell method.